All right, here we go. We're going to talk about graphing inequalities on a coordinate plane. And so this is going to be very similar to graphing a line on a coordinate plane. So think slope-intercept form, standard form, those kind of things. With an inequality, we're going to be looking at not only having a line, but then also shading to indicate answers that could be greater than or less than instead of just equal to as we would have with an equation. If we have an equation that has either, and it doesn't matter what it is, a greater than or a less than with no equal to, when we graph it, we're going to use a dotted line, and that dotted line is saying something similar to what happens with an open circle on a number line, which is it's a boundary. We get up until that point, but we never actually reach that point. Okay, if we have any inequality that has an equal to sign, again, it doesn't matter what it is, then we're saying we're going to use a solid line, and that's comparable to using a filled in circle on the number line, meaning not only is the shaded region part of my answer, but also the line itself. We call the answer that we would shade a half plane, because it is indeed half of the coordinate plane. If you just think about it, the coordinate plane is infinite in size, and so any line that goes across the coordinate plane cuts that coordinate plane in half. Even one that doesn't really look like it cuts it in half, like the one that I have drawn down here. In reality, it does, because that coordinate plane extends infinitely in all directions. Again, the line is called the boundary, and sometimes the boundary can be part of the answer and sometimes it can't. So I'll just show you on the first one what this would look like. All right. So here we have an inequality that is already in slope-intercept form, and so we're going to start graphing that just like we would graph a line. We've got a y-intercept of 3. I'm going to put my initial point there, and I have a slope of 1/2. I'm going to go up 1, right 2. And remember what we said when we were graphing lines with equations. I'm just going to extend that line as long as I can. Excuse me. And not trust my poor ruler skills, especially when we get into systems and things like that. All right, so there's my line. If it was an equation, I would know I would just put a line through it and I'd be done. It's an inequality, and so there's a couple of things we have to look at. First off, there's no equal to sign, and so I have a dotted line. That dotted line tells me that it's the boundary between answer and not answer. It's the boundary between my shaded half plane and not, but it itself is not part of the answer, and I'll show you what I mean by that once we get through this. Okay, so now this says all of the y values that are greater than 1/2 x plus 3. And so there's a bunch of ways we can look at this. Y is greater than. The y values that are above are here. And so every coordinate in that shaded region should make this inequality true. And every coordinate in the non-shaded area should make that inequality false. So let's pick a point. Let's check it. Let's go. -3, 4 is in the shaded region. So if I plug in -3, 4, 4 is the y value. That should be greater than 1/2 times -3 plus 3. 1/2 times -3 is -1.5. Negative 1.5 plus 3 is 1.5. And 4 is indeed greater than 1.5. And so that tells me that point is in the shaded region. On the other hand, if I were to pick a number, or excuse me, a point in the non-shaded area, 5 comma negative 3. Negative 3 is the y value. 1/2 times, I keep picking things that are going to give me fractions, not smart. So 1/2 times 5 is 2.5. Plus 3 is 5.5. And guess what? Negative 3 is not greater than 5.5, which is why we didn't shade that area. So the difference between an inequality and an equation is with an equation, all the points on a line make the equation true, whereas here, every single point in that shaded half plane will make this equality true. The fact that this is a dotted line means that line is only a boundary and not an actual answer, not an actual solution. So if I pick a point on the dotted line, what is that, 2 comma 4, and I plug that into the original equation. 4 is the y, 4 is greater than 1/2 times 2 plus 3. 1/2 times 2 is 1, plus 3 is 4. And so you can see what happens here. 4 is not greater than 4. That is a false statement. And so that's the reason why those points that are on the boundary, in this case, are not part of my solution because they don't make the inequality true. All right? And so again, the answer is everything, every possible point in that shaded region above that line, okay? Where the y values are greater than 1/2 x plus 3 there. All right, next one. They try to tricky you, but I'm just going to turn it around and I'm going to say, whoops, that's a highlighter. Y is less than x minus 1. I'm going to start on negative 1. Slope is 1, up 1, right 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 1. Bop, 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 bop. Dotted line again. Because there's no equal to. Meaning again, that should just be a boundary and not a part of my answer. And now this says we are going to shade all of the y values that are less than or below that line. And understand that above or below are relative terms depending on the line. And we'll talk about this in class and we'll look at how that could get confusing a little bit. But it is relative to the given line. So under that line, that would be here. And then we'll pick a point and see what happens. We should be able to pick a point in that shaded region and it should make it true. And if it does, then we know we have shaded the correct side. So I'm going to pick, what was that? 3 comma negative 2. 3 comma negative 2. I can plug it in after I've turned it around or into the original. Either way, it doesn't matter. So negative 2 is my y value. 3 is my x value. Negative 2 is indeed less than 2, and so that means I shaded the correct area. Your book will always talk about using 0, 0 as a test point, which you can do, but then you have to be prepared to say, well, it should work or it should not work, depending on which side you've shaded. All right, so here we have an equation that is not in slope-intercept form. So you can either put it in slope-intercept form, get the y alone, and then graph it using slope-intercept form, but we also know other ways of graphing. You could graph this using standard form. And the reason I want to talk about that is when we get to the word problems, there will be word problems that are set up like this, and we graph in standard form using x and y intercepts, and those x and y intercepts are very key points in analyzing the meaning of the word problem. So we'll just talk about doing that now. Reminder, if I want to graph using x and y intercepts, the definition of an x-intercept is a y value that's 0. So when I'm going to do my x-intercept, a cover-up method, plug 0 in for y, it makes it go away. We could pretend that's an equal sign for now if it makes it easier. My x-intercept is 9, 0. And again, remember, I know that the y value is 0 because I am the one that plugged the 0 in the first place. So there's my x-intercept, 9, 0. Then I'm going to find my y-intercept, and my y-intercept would be when I plug 0 in for x. And your y value is 6. And again, I know the x value is 0 because I plugged it in, so 0, 6. And there we go. And now this one gets a solid line, not dotted, because it's got an equal to. Oh, that was really good. That was pretty good. And now we are going to shade above that line, relative to that line, and that would be here. All the points that are greater than that line. Now for this one, the way it's set up, before we were saying all of the y values that are greater because it said y is greater than. But in this one, you have both the x and the y on the same side of the inequality. And for this, it is every point that is above 18. So what does that mean? We'll pick a point here in the shaded region, 4, 5. If I plug in 4, 5, 4 is the x, 2 times 4 plus 3 times 5 should be greater than or equal to 18. That gives me 8 plus 15 should be greater than or equal to 18, and it is definitely greater than or equal to 18. It's greater than 18. So all of those points, upon plugging in the x and the y values, will give me a value that is greater than 18. In this case, if I pick a point that is directly on the line, because of the equal to, it will be exactly equal to 18, which makes the line itself a part of my answer as well. If the line is dotted, the dotted line is only a boundary. If the line is solid, it's equal to. That means the line itself is part of your answer. All right? Do another one here. This is kind of a special guy. So if you look at it at first, you say, oh, the y is missing. So if you remember, I'm going to subtract. I'm going to isolate my x here. I get negative 2x is greater than 6. Divide by negative 2, and we're going to have to reverse our symbol. X is less than negative 3. There is no y value here. This is one of our special cases of linears that we talked about, and we would always use that little phrase Hooivaks. This is going to be a vertical line at, before would be x equals negative 3. Here, the fact that it's does not have an equal to tells me I'm going to have a vertical line at negative 3, but it's going to be dotted because I'm not equal to negative 3. So in this case, I'm not saying where are the y values greater or less than. In this case, I'm saying where are the x values that are greater than less than. This says where are the x values that are less than negative 3. Well, that would be -4, -5, -6, and -7, and -8. And so for this, when we talk about greater than or less than, we're not talking up and down, we're talking left and right. So everything to the left of this line is part of my answer region, because that's where all the x values are that are less than -3. Picking a point for these ones are kind of weird, but it works. If I pick a point to plug in, I say, here's -5, 1. Well, I don't even have a location to plug in the y value, and it really doesn't matter. I plug in the x value. The x value is -5. Is -5 less than -3? Yes, it is. Boom. That means I shaded the correct side. And that's as far as we'll go for today, and we'll talk about maybe some other interesting cases tomorrow, and also we'll get going into some word problems on some of these as well. All right, have a good day.